thanks Tobias and Susie and Mark for inviting me, and sorry about basically the whole sort of rescheduling business. So I'm going to talk about learning to interact naturally with all users, and there are essentially two keywords here which are important. One is all, and the second is naturally, right? So what do I essentially mean when I talk about learning to interact naturally? Why do we really care? Now, all of us, we are sort of using these computational tools in every sort of day of our lives, right? So, tools like search engines, Google and Bing. And then there are tools like recommendation systems like Amazon and Xbox Live. And as a computer scientist and a machine learning sort of researcher, I'm interested in making these systems more intelligent. So the first question that sort of came to me was, how do you sort of define something being intelligent? When you are talking in terms of a human and a human being intelligent, we have different sort of metrics. You can sort of measure IQ, but would you sort of measure the intelligence of a machine by sort of ranking them on a IQ test? That doesn't sort of seem right, right? So what does it mean for a search engine to be intelligent? What does it mean for a recommender system like Amazon to be intelligent? Okay, so these are the sort of questions I'm sort of interested in. How do you make a system an intelligent system? Okay, so to just explain some of these ideas in more detail, I'll try to give you an example or use a case study. And the case study would be Kinect, the Xbox Kinect. How many of you are aware of Kinect? A large proportion. Essentially, it's a new camera or device which Microsoft launched a few years back. And instead of looking at the world and sort of giving you a picture in color in R, G, and B, what this sensor was able to do was actually find out the depth of each point in the image. And it's a sort of the price point is not very difficult, and so a lot of people sort of bought this device. So what does it enable? So I had a video, but I won't sort of go into sort of what it can be used for. It was primarily used for sort of gaming, but soon people realized that it could be sort of used for building natural user interfaces of all different types. So just to summarize, it is a sensor which allows you to sort of track 20 body joints in real time. So the camera is just looking at me, and I'm sort of moving my hands, and it is able to very accurately estimate how different points in my body are sort of changing. And it allows you to be the controller while playing games, while interacting with your media player, so on. So now you don't have to have a remote. You can just sort of do actions or movements, and it will sort of understand. So what is the underlying technology? So this is sort of an input that the Kinect sees. So this is like an image where the pixels which are brighter are closer to you, and pixels which are darker are far away from you. So this is essentially what the sensor gives. Now what you need to do with this signal is you have to sort of understand what is the pose of the person, right? What are the different body part positions? And this mapping is what is the main sort of problem when you're trying to sort of infer the pose of this person. So how do we do it? We essentially train systems, machines, and machines are like dumb students. You have a bunch of pairs of inputs and desired outputs, right? And what you want to do is basically, given a huge set of inputs and outputs, you want to give this to a system, and this system is going to learn this mapping, this function f, from the input to the output. Okay? Now, if you give a bunch of examples to a student, they will be able to understand it. But machines are really, really dumb. So they have to be given a lot of these examples to really find out the relationship between this input and the desired output. So how do you do it? So you capture tons and tons of these pairs of depth images and the position of different body parts, right? And essentially 1 million of them, and these sort of cover all different types of poses, the locations of the scene, different types of heights and weights, genders, clothing, and hair. And then you essentially train the system. So what does the result look like? So this is an example. This is what the camera sees. The system is now able to sort of classify each pixel in that camera and sort of label it with different it could assign it a different body part label, and then you can sort of get these estimates of different body parts, body positions. Okay, well, this is great, right? But we are not done yet. So what is the task which is remaining? The task which is remaining is actually a much more difficult problem, which is to find the mapping between this space of movements to the actual user intent. So what did the user want to do while he was making a movement, right? Suppose he wanted to raise the volume of a media player. So what was how would you define this mapping? So how this was done earlier by game developers was, here's a game developer, and he wants to, say, detect the action punch, right? Now what they would do is basically they would say, let's see this point on the hand, and if it is moving with some velocity, I will call it a punch. So you define a set of if and then statements, and then you hand code these rules and build a system. The system in this is then tested on a bunch of users, and then you will get the feedback, and it will be given to the developer saying, okay, this system does not work on 20% of the participants, and they were doing punches like this. So you now have to devise a rule for people who punch like this rather than punch like this. Okay? And this sort of process repeats. Now, it would be great if you could do something in the more machine learning fashion, where you just, again, collect training data, input and expected outputs, right? And then give it to a system, and then it could learn this mapping automatically. So what is the problem with recognizing gestures of everyone? The main problem is that people have different notions of what a particular intent means. So if you are sort of thinking about recognizing the shoot gesture, some people would shoot like this, some people would shoot like this, some people would shoot like this, and you need to cover that natural variability. Okay? So essentially, you need to sort of cover all these different variants that sort of change the data. So let me give you an example. So these two subjects were told to kick to attack an enemy, right? And you can see that the kicks are quite different, right? Now, that was a simple sort of gesture which everybody knows, right? Kicking is sort of an activity that most people could sort of reason about or think about what would be the associated movements. Now, how would you sort of associate movements associated with something that you had not thought about? Start music or raise the volume. Okay? So we basically told people, raise your arms to start the music or raise the volume. And this is what people sort of did. Okay? So there is, again, sort of variability. Then this guy basically started doing this, and this guy basically. So there is a lot of natural variability, and sort of the mapping between movements and what the person was trying to do is not very certain, right? So how do you sort of go about collecting all this data? Now, again, so there are challenges. You need to sort of ensure that your training data covers sort of has humans of different sort of lengths, have like ethnicities, different age groups, different genders, and so on. So how do you get data about all users? When you're trying to build an intelligent system, how do you actually get data about all users? One way would be to use crowdsourcing, right? And this is a popular way. And there are different modalities. One is Mechanical Turk. It uses sort of a monetary incentive. You can ask people to sort of contribute data, and you can pay them a few cents. And this sort of works well. It has some problems. It has the scale issue. If you're really collecting, if you're trying to collect millions and sort of billions of instances, then it does not scale up. And secondly, it has biases. You would only get certain types of people who are on Mechanical Turk. If you are sort of trying to build a recommendation system for CEOs of companies for, I don't know, buying aeroplanes, private jets, you don't want sort of to train the system on sort of what a mechanical turco is going to tell you. Okay. Now, there are other crowdsourcing options. You can build games, right? And this has been very popular. Louis Nan, who was a researcher at CMU, who is a researcher at CMU, built the ESP game and the reCAPTCHA game, and many of you might have sort of used this. And with this, he was able to sort of collect a huge amount of data for translating or even sort of detecting text in books. Now, there are citizen science projects like Zoo Universe and Label Me, which sort of rely on other incentive structures, which are a lot of community-based or reputation-based incentives. So, as Thora mentioned, like most sociological studies and behavioral economic studies have been sort of focused on a handful of subjects in the lab, and there is artificial lab setting, and these studies are well known to be weird, right? Essentially based on westernized, educated people from industrialized, rich democracies. Now, we thought with Thore to actually think about doing such research, but now in the context of Facebook. Now, with Facebook, you have 800 million subjects. So this basically tells you the age of the slide, because now this number is bigger, from all over the world and so on. Okay, so we sort of did this, we took this approach for two different types of projects. In the first project, we wanted to understand, can we predict what is the personality of people who sort of browse for weather or go to sort of websites like weather.com. And of course, you can sort of make predictions about people who go to weather.com are cautious, are organized, are outgoing. I mean, there's not much signal in whether they are being competitive or cooperative. We also used it for studying how people sort of behave in strategic situations. So there's kernel blotter games is basically a sort of a key concept in sort of game theory. It's a family of games, and we studied how people play these games and do their behavior matches with what is predicted by theoretical analysis. And we found that the behavior actually did sort of match with what was predicted by theory. Now, although you can use this sort of method, there are a number of limitations, right? Facebook's profiles are managed profiles, right? People are trying to convey a desired impression. So the type of data that you might be getting might not be really true. And also, you can only capture a limited types of interactions. So coming back to the Kinect study, this is the second sort of notion. So the first was basically trying to get data from a large number of users, and the second was trying to capture a sort of natural user behavior which was free from sort of these framing biases. So one key question that we wanted to study was, does even the way we tell people to use the system change the way we change the data that we get? Okay. So what do I mean? So we conducted a study with 30 people, and we showed them, we told them that we are collecting data for 12 different types of gestures. And these are two categories of gestures. Iconic gestures, which everybody sort of knows about, like hide, shoot a pistol, throw an object, change weapon, and so on. And then some sort of gestures which people would not really know about, things like raise volume or navigate to the next menu. People don't generally associate sort of movements associated with these gestures. So now we wanted to test how to collect data. So we said the first way to actually collect data is just to instruct them by giving them some textual information. Raise your arm to sort of start the music or raise the volume, right? And then as you saw, people were sort of raising their arms like this, like this, like this, and so on. So there's a lot of variability. So then somebody said, well, don't just give them text, show them images, like you see in sort of in flights, right? That if you have a set of instructions, you have a set of figures and then with some arrows. So in order to sort of test this, we had a gesture called navigate to the next menu, and we sort of had 4 or 5 photographs, so which basically showed a figure doing in these 5 different poses, and then there was an arrow saying that this is the order in which you should do it. Maybe 60 or 70% of the people sort of did it, and then the rest basically did this. So somebody then came up and said, oh, you guys have got it totally wrong, just show them a video, right? This is fine. So while showing the video, while shooting the video, which was supposed to be an instruction material, my intern basically just put his hand in his pocket. And then he was basically doing this move the tempo of the song, and he was supposed to do this, but with his hand in the pocket. And somehow people thought that was very important. So we had like tons of data with people with their hands in the pocket, which was not necessary at all. So then we basically thought, okay, let's try different combinations like images plus text, videos and text, and so on. Okay, so things like this. So what happened? We collected all this data, and then we tried to study what really happened. Now, if you train the system using data collected from these different modalities, you see these sort of effects. So if you just use text, the accuracy is very, very low. And when you show videos or video plus text, the accuracy is very high. Now, this is for the music player sort of set of gestures, where people did not have a notion of which movements are associated with the gesture. When you come to games, where people do have a notion of what is associated with the gesture, this effect goes away. Now, even textual information is good enough. Okay? So I won't go into the details of this study, but if you're interested, I can sort of discuss it later. So the next sort of study I did was understanding the context in which this data is collected. Now, when we think about user preferences or what users want, we seldom think about the context in which that data is being given or the data is being collected. So let me give you an example. Suppose I want to go to a restaurant. Now, the type of a restaurant that you would recommend me would depend on who I want to go to the restaurant with, right? If it was with my office colleagues, it would be a different kind of a restaurant. But it was with my family, it would be a different kind of restaurant, and then so on, right? And this notion of the context or group preference is sort of missing in all recommendation systems, right? So we tried to do the study whether there is an effect like this. So we did a study in which we were looking at how do groups view different types of events or different types of sort of TV programs. So they were sort of categorized into general documentary, news, general drama, sports events, situation comedy, and so on. Now, if you just look at the individual male, a single male who is just watching alone, then this is sort of the ranking that you get. Okay? So a single male would basically is more likely to watch general documentaries and then news and so on. Now, any guesses on what would happen in an all-male group? Which activities go up? Any guesses? Sports. Yeah, that makes sense. So sports goes up, right? Now you can do the same thing with females, right? So females, this is the preference list. Now what happens when females are in a group? In females, the situation is different. So news actually just drops away like males, but instead of sports, now there is general drama. Now comes the interesting question. What happens in a mixed gender group? So there's a male and a female watching. Okay, I can give you a hint. It would be either general documentary or general drama. Yeah, you know who wins. Yeah, so it is now general drama, and now you see some other interesting facts. Now, all male, the male group did not like news, but the mixed gender group was happy with news. So apparently, couples are happy watching news together, but they wouldn't watch it with sort of their friends, right? Now, if you go down and dig into what is really happening in all these different types of contexts, you can see that for certain categories like general documentary and news, the group structure actually makes it less likely for that type of item to be viewed, right? So you have these sort of inversion effects. On the other hand, things like feature films, the group actually increases the probability of that particular event happening. So I'll try to conclude by just showing this one particular case. When we are building these intelligent systems, it is sort of becoming it is very, very important to understand how do users sort of behave and learn with these systems. Now, if I asked you, what would be the user performance with these 3 different kind of cars? So this is the automatic DARPA car, this is your normal Mercedes, and this is the Formula 1 car. Now, the performance with the naive user who does not know how to drive would be this, right? And the performance with basically the sophisticated user is going to be this. Now, when we are designing these systems, who are we sort of optimizing for? Are we optimizing for the average user? Are we optimizing for the best user in the hope that, well, one day everybody will sort of know how to use the search engine, although they don't know how to use it now? Right? So these are questions that as system designers, as machine learners, we have to sort of think about. And here user understanding is very, very important. Okay? So I'll conclude by saying big generally, like people throw this term big data a lot, right? And big does not always imply good. It has to sort of really cover all the possible variations for the prediction problem you're interested in, right? And there are I'm sure I don't need to preach to this audience. There are biases in your data which you really need to take care of when you're building these systems. And finally, there is dynamic user behavior, and users are learning constantly. So you have to sort of reason about the equilibrium performance, not just what the system is going to perform at the moment it is released. Okay, with that, thank you. And if you have any questions.
So thank you very much. Do we have any questions? Or signs that people have not been entirely exhausted? Okay.
Can I ask my own colleague a question? So the users are also learning agents.
Mm-hmm.
For example, with the Palm Pilot, while the interface was inspired by letters and gestures, it was a particularly normalized system of entering text.
Mm-hmm.
And so users could also be expected to do their bit and adapt to what the system is expecting of them,
mm-hmm.
right? Can you comment on how those 2 learning systems would interact?
So, that's a very interesting question. And there is this notion that when sort of system designers were building tools like the car, right? So if you think about the car, the actual car interface has not changed much. There is an accelerator, there is a brake, and then there is a clutch, right? And there are automatic cars which basically have a certain different interfaces. When we come down to sort of interfaces that we see in the IT space, right? Search engines and recommender systems or mobile phones, apps, and so on, they are constantly sort of changing over time. Now, of course, there is this notion of learnability, right? You basically pitch so there are 2 schools of thought, right? Either you can sort of optimize for the current user behavior, or you can be Steve Jobs, and you can say, people really don't know how to use the interface. I'll build a new user interface, and people will then sort of learn to use it, right? So in some sense, there is this area of there is this sort of magic design sort of knowledge that has to be injected at that point of time about how to sort of reason about equilibrium performance, where you have actually no data at all. You might have certain sort of raw signals like do people like to pinch, or do people sort of find it natural to sort of zoom in and so on, and you can sort of build on those sort of construct, but you would not get any sort of actual data unless you actually deploy the system.